Well, normally I would solve this algebraically, and I think that's the best way to do it, and I encourage you to do it in the forums. But since we already calculated Vmax numerically using the numbers I had made up last time, k equals 500, m equals 1, and xmax equals 0.2, let's go ahead and get ourselves an answer. So how do we do this? Well, I know that this system has some total amount of energy. When it's at the extreme points, that energy is all potential. In the equilibrium, it's all kinetic. In this middle point here, it's both kinetic and potential. I could phrase this mathematically as the total energy is going to be the kinetic plus the potential. Well, the total energy is just whatever energy it had when I pulled it all the way back to x max. The kinetic energy, well, I'm not sure what that is, but I know this is the equation that describes it, and actually I know all of these numbers, except for v. To solve this for v is just a matter of doing a little bit of massaging, which I'll leave to you, and when I carry out all of this algebra and arithmetic, I find that when I'm at this point, when the mass is moving through this position here, the velocity is 0.87 its maximum velocity. 87%. It's moving pretty fast. So on my plot, I'll go up here, and probably somewhere around here. Now I could do very similar algebra to find that there's also a negative solution. And this solution corresponds to the exact same thing, but when the mass is moving this way. I could also find that there's solutions over here. And if I solve for the position when the velocity was 1/2 of its maximum, I would get 0.87 xmax, so I could put points here and here. Can you see what shape is starting to emerge in the points we're plotting? It's a circle, or at least it's supposed to be. Sorry, some of my points are a little bit off. This is something in physics that we call a phase diagram, and it's a very powerful tool once you understand how to use it. The way to interpret this diagram is as follows. We start with a mass pulled all the way back to x max. We let it go. Well, in this case, it starts with negative velocity. It moves that way. So that would correspond to going into the negative realms of velocity down here. Eventually, it maxes out in speed as it passes through equilibrium, but keeps moving to the left, as can be seen by the negative velocity. Eventually, it reaches this extremum over here, and finally it turns around. Positive velocity, moving to the right. Passes through the equilibrium, maximum speed, keeps moving to the right, and returns to where it started. The Wikipedia page on simple harmonic motion has a really great illustration. Now, a couple things to notice that are different about this illustration. Position is vertical, velocity is horizontal. The spring itself is moving up and down, but you get the same idea. Here, the vertical position is tracking the object's position, and as the object moves downwards, we see that the ball is on the left side of this line, corresponding to a negative velocity. As it moves upwards, this ball is on the right side, corresponding to a positive velocity. Okay, so why did I spend all this time to show you this?